In section 3.2, we're going to talk about measures of variation. Specifically, we'll start with the first one, which is range. And our range for any data set is just the maximum, the highest value, minus the lowest value. It's the range of all the values so that you know how many numbers you're covering. We actually did talk about this when we talked about finding the class width. When we were calculating classes for our frequency distributions in the last section. We'll also talk about what's called standard deviation. This is what we're going to actually probably use the most throughout this semester. We have two symbols, one for population standard deviation and one for sample standard deviation. For sample standard deviation, we'll leave it nice and straightforward. We'll just use a regular S. For population standard deviation, we're going to make it a little bit more complicated, and we'll use the Greek letter sigma. This is a lowercase sigma for population. Now, if you continue along, you'll notice that there are two formulas for standard deviation, one for population, that's for sigma, and there is one for sample standard deviation, S. Notice they may look quite a bit different. Notice that they may look quite a bit different, but they actually aren't. The formula tells you to take each data entry, that's what the X's are, and then after you take each data entry from your list of data, they want you to subtract the mean. Now, when they use this mu symbol, remember that's just the population mean. If they call it X with a bar, that's just the sample mean. So they want you to do that for every piece of data. They want you to take each piece of data, subtract the mean, then, be careful, they want you to square it, and then you'll come up with a whole list of each data value minus the mean squared, and then notice what's out in front of that is a little sigma, a capital sigma, which means that you are going to add up all those values you just found, where you took each data value, subtracted the mean, and squared it. Then at the end, here's where the difference between population and sample is. For population, you just divide by the sample size, n. For sample, you actually take the sample size and subtract 1. And that's what you divide by, which means you actually do get two completely different standard deviation values for either the population or the sample based on the problem, because you're dividing by different numbers. They'll be pretty close, but they won't be exactly the same. So keep in mind when we read our problems, it's going to be super important to know whether or not we're looking at a population or a sample. Now, what we're going to talk about in this course is we don't actually want to use the formula. If you want to, by all means, you can. It's just super involved. You can tell that. It's a lot of subtracting, squaring, and then adding and dividing. Oh, and I did forget, at the very end, you have to take the square root, too, of whatever you're getting. So once you take each data value, subtract the mean, square it, take that whole list, add it up, divide by n or n minus 1, depending on if it's a population or a sample. Then at the very end, you're still not done. You have to take the square root. So what we'd like to do if we can is use our calculator rather than doing all this by hand. So that's what we're going to look at. But the formula does work. It's just time consuming. So all the steps are written out in words if you need it. Is again, you'll take all your data values, subtract them from the mean. That's your first step. Then square them. That's your step 2. Then step 3 is take that whole list, add them up. That's what we're saying here in 3. And then in 4, we're going to take whatever your sum was and divide it by either n or n minus 1, and that is a big difference, so be careful that you know whether or not you've got a population or a sample. And then, like I said, the last step is to take the square root of everything. Whatever your final answer is, it will be after you take that square root. However, If you're asked to find the variance, don't take the square root, or you're going to have to take your standard deviation and square it. Variance, whether it's population or sample, just means that you're taking your standard deviation and leaving it as squared. So always to find your variance, you're going to take your standard deviation and square it.